most important question of the day, at least for this talk. Why are we talking about GitHub? So, I think all of you know this by now if you're here, but GitHub is now something that us non-technical people can use and kind of contribute to. And that's because the AI can write code for us. That's really what it boils down to. So I know this is all obvious if you're here, but I think it's really important to understand how much is going on GitHub that we basically all kind of have to find a way to pay attention to if we can, especially for doing work and in tech or tech adjacent companies or working in tech. So basically what's going on now is that there are many non-technical people that are now also creating and sharing their own GitHub projects and other projects. So we can say we're here because of AI. I think you know that's the really truth of the matter because it's made it so much easier for all of us to contribute in a way that honestly we've never really been able to contribute before. So yeah, that's why we're talking about it. I think the big thing is when you look at it though, and you land on a random GitHub page, it can feel really foreign. I mean, for the longest time, even until not too long ago, I wasn't as comfortable with it, even though I was already writing code with AI and stuff like that, as I wish I was. And now I feel like I understand it extremely well. And it didn't really take that long because the bots and the AI and all that are sitting there sort of writing the code for me. And now you even have engineers saying they don't read the code. So they're not much different than us, sort of, now in terms of maybe even skills. Just kidding. But it's true because like AI can write the code, AI can explain the code. They're not reading the code. Some of the best engineers in the world are saying that now. Obviously, some of them work at the AI lab, so of course they're going to say that because they have unlimited tokens to spend or whatever you want to call it. But it's true. So, all right, just to kind of give us kind of something to strive for here. By the end of the session, you should understand all the different words that are running around GitHub, the important ones. There's tons of words running around and tons of code running around, but that standard kind of terminology is what the goal is today to just understand. You'll know how to open a repo and also know what you're looking at in it, although you can just ask the AI. So, that's not a high bar anymore. And then you can figure out how to get these project files out of GitHub, zip them up, do what they call cloning, or not, they call it cloning, but essentially you could clone a repo and stuff like that. And then, of course, how to point Claude Code or Codex to a repo and actually let it do something, because that's kind of sort of the next level after you understand the terminology and all that stuff. Okay, so the basics. We're going to just start with absolute basics. What is GitHub and what is a repo? So GitHub, okay. So I'm going to date myself, but I actually existed building software with engineers before GitHub existed. So before GitHub existed, and the reason it's called GitHub is because there was this tool called Git. And what Git did was help essentially engineers track the changes that are happening on a project's files. And I think that's something that folks might not sort of care to know or learn. And I agree, you probably don't need to learn Git in any kind of way, shape, or form. But what you should know is that the reason it's called GitHub is because what essentially GitHub did is took Git, and to be honest, they could have taken a few other versions of this kind of code changing thing instead of Git, but then it wouldn't have such a cool name like GitHub. So I think they took Git, or not I think, they did, and they basically put it online. And that was the big innovation for engineering and actually what I think exploded open source and even just how we write code and all that stuff. So they basically put Git on a website and they made it so you could share this stuff between people by just sharing a link. So it was a big deal when it came out, and there's no surprise that it's so big right now as a result of how it started and what the main goal of Git in the first place was. So the TLDR here is GitHub is something called Git in the cloud, which makes it so we can easily share code and access code and all that kind of stuff. And of course now, in the past, it was mostly engineers. I say mostly, but it was basically all engineers. Now, some of us product managers and stuff, and then when the engineers gave us access to it, we could mess with it and do stuff. I definitely did some things with it a long time ago, but nothing that I'm proud of or feel like was great code or anything like that. I'm not an engineer either. But now with code generation and AI being able to generate code, in all these tools, so many different tools, we have non-technical people like me and many of you, if not all of you, actually using GitHub. So that's really why I think the world has just completely changed. But because GitHub exists, this is actually possible. Something like it would need to exist for everything I'm talking about. And honestly, everything we're doing with AI, because it's a centralized place. Nobody owns it. Yes, I know Microsoft owns it, but they haven't messed it up yet. And I don't think they can at this point. Plus, companies are trying to do some new things. But at the end of the day, this is where all the heat is. This is where all the developers were. And now many of us are there too now, or can be. Okay. So the main part of GitHub is this thing called a repo, or, that's short for repository. And all it is a folder. Let's just call it a project folder. Maybe it's like the simplest kind of way to kind of explain what it is. It's just a folder. And it is the main object or thing inside of GitHub that you're going to be interacting with and looking at all the time. And it essentially has all the files for one project, plus the full history of edits of every file and everything that's been edited, uploaded, put into the project, all that kind of stuff. And I think all of you might know this by now, but there's public repos and there's private repos. So public repos tend to be all these open source things that are out there that I've talked about before, or like if you make a skill and want to share it with the world, you can go to GitHub and post your skill there, make it public. Boom, done. It's open source, it's sitting there. Then the private parts of it are if you work usually at a tech company or have engineers on your team, they're probably using GitHub in private. You've probably paid for an organization or something like that in GitHub so that you can take the code and make it private and all that kind of stuff, and then collaborate on it with engineers and their teams or your teams. So that's basically it. The repository is the main thing. And that's how basically all of GitHub basically works. So, next step, we're going to talk about 7 things. And these 7 things are going to help you understand how to use GitHub. And more importantly, in this case, how to use a repo specifically. So I'm just going to jump right in. Simply put, you might feel like opening a repo, which really just means looking at it and looking at a bunch of web pages, which is why GitHub's so awesome. It can feel a little kind of overwhelming because there's a bunch of stuff going on. It's really a list of files and stuff like that. But just to clarify, the middle column, when you open up GitHub, there's sidebars, but the middle column is the project's files. And the right column tends to have a summary of what it is, how popular, who's behind it, etc. And then the tabs across the top are kind of the work, the code, the issues, the pull requests, all these things that kind of are happening. But don't worry, I'll explain all of them. My quickest first thing I do when I look at a repo is I go to the README. A lot of these repos have great READMEs. Some of them might not, but a lot of them do, especially these days when the AI needs to read them, us humans need to read them, engineers need to read them. Yes, engineers are human too. So it's usually on the front page of the repo, and it just explains what the project is, how to use it, and it's usually written in plain English. Sometimes it has some AI slop in it these days. That's okay. You can get a good idea of what that repo is all about really easily. And if you read one thing or try to look at one thing, this is the thing. This thing can usually really quickly tell you whether this repository and what you're looking at is useful or interesting to you. And, I'll talk about some low-hanging fruit in a second of how you can just practice this or look at it. But really simple stuff. The README is the key when you look at a repo, and that helps you understand everything about it. It's basically an introductory sort of, it's like the introduction to a repository. I think that's a good way to think about what a README file is. All right, next up is branches. This is one of the coolest concepts in Git and GitHub. But basically, the idea here is that their branches are essentially duplicate or parallel versions of the same project. And they call the main project main. So that's like the stable one, and default branch. What that really means, stable or default, if you want to get into the terminology, is like that's the one you're supposed to use that everyone's using that is not being worked on actively. The branches are what get worked on actively. And every branch has its own work in progress and things that need to be reviewed. And eventually it gets folded back into main. So if someone says, I branched the repo and I'm working on it, or even if they say they're working on it, they likely branched it. So took a clone of it at the point in time that they took the clone and then are working on that, and then we'll merge it back. There's other, concepts that we can talk about around like rebasing and all these fancy things, but you don't need to worry about any of that. Those are all things that if the main project drifts from your branch, you might have to do some things. I got to learn these things not too long ago because I was messing with code and people would ask me to rebase it because there was all these changes in the main project. Again, gets more advanced, but the simple truth here and the way to think about it is this allows people to make changes without impacting the main version that's already being deployed and should be deployed. So the main version is supposed to be stable and something that you can deploy while these branches are when people are working on things. So when you see branches, that's what that means. Contributors. I know this is a super obvious one. I do want to mention a couple things here that are really interesting, but this just shows people who have helped build the repo. And even me as a non-engineer, my face shows up in a few of these now because I've contributed to a bunch of different projects and people have also accepted my changes. But we'll get into that in a bit. But anyone whose changes have been accepted show up here, and it's actually a quick read on how active is the project actually, because if there's a lot of contributors, that means it's probably pretty active. So it's one way to read that. One other thing about contributors before I get into forking is that you will actually see the Claude logo there, and that means Claude was a contributor. It's actually one of the ways that Claude Code initially spread because people would see this, click on it, and you'd see that was a contributor and go install Claude Code or whatever if you were interested. Really cool thing because the AI is able to write the code too. So if you're using Claude Code, there's a chance Claude Code is actually writing the code and even saying that it's writing the code. There's a setting in Claude Code to change that. Okay, forking. So forking is different than branching, but what it really means is that you're essentially making your own copy of the repo on GitHub. And again, it's a moment in time copy and it doesn't automatically get the updates and doesn't push back changes to the main repo. So you're essentially just taking it, making it your own, and you can change it freely. Of course, there's some things around licensing of the code. All I'm usually looking for is an MIT or some Apache license. Those are usually at the bottom of the README. Again, more advanced, not things you need to worry about, on the sort of basic level if you're just trying to understand GitHub. But essentially, you can change anything with a fork, and it means that it's your own version you can build on. But the goal isn't to go merge it back. That's usually when you want to create a branch, not a fork. So this is just a way to make it your own and keep it in GitHub like you're actually copying it to, for lack of a better word, steal it. But you're allowed to do that. Again, the license thing we can get into. Okay. And then cloning is essentially when you make your own copy of the repo on your own computer. And that's kind of an important concept as well, because with that concept, you can still pull updates from GitHub whenever the GitHub versions change. And that's the difference between forking and cloning. Forking is like just taking it off, doing whatever you want with it, and not caring about the original. Cloning is when you actually do. And this is actually something that the AI tools are able to kind of do really easily by you just giving them a repo link, and then they can clone it locally or in the cloud if that's what they're doing, and then sort of start using it. So this is my fun one. I do this a lot with skills because skills, I can point an AI to skills, but I can also take a zip file and upload it. But the zip file basically gives you the entire project because the project is just, and repos are just essentially a folder with a bunch of files. So downloading the zip file gives you everything there, but it doesn't give you anything else but the files. And again, it's just like these other sort of methods where it's a one-time snapshot and you don't have any link back to the original with it. And you want to do this when you don't really care about any updates, or like I said, when there's a skill on GitHub and you need to download the zip, so you want to upload it or something like that. Same thing with a plugin and things like that. So there are a bunch of cases where you might want to do this. But again, I just want to give everyone the lay of the land and actually mention downloading the zip because it is a common thing that you might end up doing if you're messing around with skills and things like that. And that is something that a lot of non-engineers are, of course, doing. Okay. How changes happen. So I wanted to make sure I talked about this, not just kind of the basics I just mentioned. The main reason is because then you'll understand how the actual plumbing works and what all this means. So there's only 3 concepts here. So version control. So that's basically the proxy for all of us that need to understand this. It's like history, document history. Good way to think about it. But it basically means you're tracking and managing changes to files so you can review the history, undo mistakes, and essentially it helps you collaborate with others too, because different people are working on different things and committing them and things like that, which we'll talk about in a second. But it's basically version control, just like history on a document. And this is what helps people work on a project without overwriting each other and things like that. Then we have commits. So commit is essentially one saved sort of change. So it's when you take one snapshot in the project's version history, and you're essentially saying, "I'm going to commit this," and that means that every time kind of the work is saved, it's sort of recorded as a commit like this, and usually there's a short note on what changed. Now, because of LLMs and all that, like I haven't written any of these. When I write code, the LLM is doing all the work on a bunch of this stuff. So I don't even have to think about any of this if I'm messing with the code and making commits and things like that. But short of it is, it's how anyone can see like what's changed, uh, timeline of it, and basically who did it. All right. Now we're talking about, I think, the final boss here in terms of the thing I want to explain. I call it pull requests. If you're bored and go to my Twitter account, I wrote an entire article about pull requests, why they're so important. I think why they're a key piece of the puzzle. But basically, for this, it's basically how changes get proposed and reviewed. So when you make a bunch of changes, which is like a bunch of commits and stuff, and you do it on a separate branch, you're essentially requesting that those changes are pulled into the main branch. Remember, I talked about the branching and how you merge. So pull requests are essentially how you request to merge what you've created back into the main code. And this is where, you know, you get to discuss the changes, ask for tweaks, and then merge it into main. So just to step back for a quick second before I jump into some very specific tactical things around GitHub, of course, is if I if I write a bunch of code and make a commit, and then I do a pull request, that means that I'm telling the people who are responsible for letting that pull request go into the main branch and become part of the main code. I'm giving them the opportunity to review what I did, which means they might comment on it or have opinions. Oftentimes these days, you have an AI bot reviewing stuff. That you might see greptil. That's a very common one, but there's a few of these that will come up, show up, look at your pull request, because a lot of these repositories have these bots running and give you feedback on it and kind of score it, which kind of helps out those people that are maintaining a projects. With projects and repositories, there's also maintainers. These are the folks that are essentially maintaining the main branch, let's say. So the main repository, and making sure that everything that goes in there is all good. That's at least what they used to do. Now the AI is helping a lot. So oftentimes I'll make a pull request after making a bunch of commits or having the AI make a bunch of commits, and then I'll get some feedback about something and stuff like that. So I think that's a good way to say it. I think I just saw someone in the chat say a merge request is more appropriate. Totally true. But the engineers have their terms and make up shit. So we're dealing with pull requests, whatever that means. All right. So I wanted to jump into just a couple quick tutorials, so to speak. And again, I wanted to keep everything relatively basic and lightweight so we could all sort of understand it and all that. And they're, happy to answer any questions too at the end. But let me just jam through this real quick and do a speed run through this. So this is how you copy and use a public repo. So basically, to use it, you want to make a copy of it. So you're essentially cloning it. And that copy is local on your computer in this context. And when contributors push changes to the repo, you can also pull those changes locally. That's why cloning it can be very valuable for you, because you can keep pulling those changes locally and do your thing. You can also instruct the AI to do all this for you, obviously. So you don't need to understand the Git commands. If you noticed, I didn't really talk about commands or anything, because the assumption here is if you're not an engineer, the AI is going to do all the stuff for you in terms of running those commands. You kind of just have to talk about, how you want to do it, what you want to do. So, okay, you just literally go to the code drop down there, and you just copy the repo URL, which is going to sit right there. There's that copy button right underneath that gray copy URL, the clipboard sort of thing. You click that, and you'll be able to copy it, right? So now you have a link. You could also take the link in your browser bar. That should work too. And the reason I say that is because you're just pasting it into one of the tools. Claude. This is an example with Claude, but it could be Claude Cowork. This is Claude Code, but it could be Claude Cowork. It could even be the regular chat, but you're not going to be able to write code with it, but you can assess things. Codex, Cursor, Conductor, whatever all those tools are that help you write code, you can do it. I think if you're a non-engineer, it's likely Cowork is what you might be using. Might be a good middle ground. But that doesn't mean you can't use Claude Code or anything. You can use whatever you want. I do tend to like to use Cowork sometimes for stuff that's not as code heavy. And then you want to basically confirm that the repo has been cloned locally, and you can ask kind of a follow up prompt, like what skills are included in this repo, if it's something related to that. So always like to do that just to see kind of did it get it, what happened, but pretty straightforward. And then from there, you can also ask for Claude to check for updates from the remote version. That's the version that's in GitHub. If there's any changes, you can ask Claude to pull the latest commits in. And again, you would be doing this because you want to use that repository, or in a lot of cases for me, you would basically go ahead and essentially start building whatever you wanted to build and can kind of manage it in here. So, and sometimes I'm just looking to assess a repository like this, but it's nice when the system clones it and actually tries to run it. My word for it is like dog fooding. There's a lot of different words for it. That's pretty common, but it's like I want to dog food it. I want to play with it. I want to try it, etc., and just see how it works. Okay, and then finally, since this stuff hopefully is not that intimidating, if it was before, hopefully now it isn't. You maybe want to create your own repo and connect to it. So this is how you do that. You go there. You'll see create repository running around. Create your first project if you haven't created one yet. And you'll basically see an interface like this. You could also have the AI create a project too, but I wanted to show how it's done a little more manually here. But basically, you would create it, then you get this form that's sitting right here. You have a bunch of settings and things like that. Let's say, I mean, those are pretty straightforward. And for these demonstration purposes, I don't have a specific use case or anything, but wanted to just show how to do this. So once you've created a repo in GitHub, you can copy the repo URL, paste it into Claude, and you've just been able to clone your own repo. And this time, though, because you made it, you have the permission to write to it directly, the main branch and stuff like that. So that's why I wanted to mention this, because this is what makes you a maintainer, not just like a contributor, but actually a maintainer of this repository, which means you're the one that's responsible for writing to it. So if you just want to play around, you can do this. And you can even go to Claude then and say, hey, make this repo into XYZ. If you have GitHub connected to Claude, it can make a repo for you if you have the appropriate write permissions. But this is a quick way to do that. So you can actually click the buttons in GitHub if you want to see how that works. And in this instance, I just asked Claude to push a folder of skills to the GitHub repo. So simple thing here. And then after this, Claude made a commit, pushed those changes to GitHub, which are basically now live. And if I wanted other people to push skills to this repo, they could clone it and all that. So think of it this way as now the project, I can create a project just like I could create a doc in Google Docs, and it can do all the things, and other people can do all the things with it within all those rules around pull requests and stuff like that. So, but basically, what you should do today or tomorrow or as soon as you want, if you haven't done this yet, is actually just open a random repo, whatever it may be. The example I gave was like Claude Anthropic skills right here. You can use that repo, really cool repo. It's very relevant to all of us because this is where Anthropic has put all of their skills. So this is where, when you go into Claude and look at the skills, this is essentially where they come from. And you can start messing around with this. This is a really good test though, because it'd be cool to just take the skill, put it in Claude, Cowork, Claude Code if you want to, Codex, whatever, and basically just say, what is this all about? What are the skills here? And if the system already knows a bunch about you, you can even say, hey, what skills are interesting and useful for me? And then if you want to go a little further, you can, get into installing them and all that. But that you probably don't need to do because the skills sit in Claude skills and their customization area and all that. But this is a really good example of how you can get your feet wet if you haven't done this yet. And again, today I hope I made GitHub much less intimidating and some of you start doing some things in there. If you make a commit, make an open source repo or anything like that, please feel free to share it with me. I'm always happy to take a look at things and all that, and always interested in what non-engineers are also building, not just engineers.